7.1, Video 3. How are we going to use these sine inverse functions? 7.1 really just deals with what happens when we nest these functions. Okay, usually inverse trig functions, when you do the inverse trig function of, or when you do sine inverse of sine, usually they cancel out. Right? That's what inverse trig functions do. But because of the restricted domain on each of these, it's not always the case. Right? So when does sine inverse of sine, when will these cancel out and equal x? Right? And when won't they? Okay, and so I've kind of put all 6 cases here. So what you have to ask yourself is x in the domain of the inside function? Right? So when we do sine inverse of sine of x, we have a regular sine function here. Is x in the domain of sine? Not in just the domain of sine, but the restricted domain of sine. Okay, so these will cancel if x is in the restricted domain of sine. So the answer is if x, remember what the restricted domain of sine was. It was from negative pi over 2 to pi over 2. So if x is between negative pi over 2 and pi over 2, if it's an angle in quadrant 4 or quadrant 1, then these will cancel out and we just get x back out. Right? So over here, sine of sine inverse, now the inverse trig function's on the inside. So we have to ask ourselves, is x in the domain of sine inverse? So you remember what the domain of sine inverse was. The domain of sine inverse was the range of sine. And so the range of sine, negative 1 to 1. So this will happen if x is between negative 1 to 1. Okay. Now on this side, if x is between negative pi over 2 and pi over 2, they're going to cancel and we're going to get x. Now if x is not an angle in quadrant 1 or quadrant 4, we have to evaluate what this value is and then change it to a quadrant 1 or quadrant 4 angle. So you know how sine of pi over 4 is 1 over rad 2. Well, so is sine of 3 pi over 4 is also 1 over rad 2. So if we get 3 pi over 4 in here, we're going to have to change quadrants, and I'm going to show you how to do that. Okay, so let's go ahead and continue. Cosine inverse of cosine. So cosine x is on the inside. We have to think about what the restricted domain of cosine was. So these will cancel if x is in the restricted domain of cosine, and cosine was restricted to quadrants 1 and 2, which is from 0 to pi over 2. Right? So if x is between 0 and pi over 2, then these will cancel and we just get x out. If this angle is not between quadrant 1 or 2, we're going to have to figure out which quadrant it is in, okay, and translate it to a quadrant 1 or 2 angle. Right? Same thing here. Cosine inverse is on the inside. So what is the domain of cosine inverse? Well, it's the range of cosine. So this is going to be if x is between negative 1 and 1. Right? Because the domain of cosine inverse is negative 1 to 1. Right? If tan inverse of tan x, we have a normal tangent here. So we have to ask ourselves, is x in the domain of tangent? Is x in the restricted domain of tangent? So the restricted domain of tangent was negative pi over 2 to pi over 2. So if this is true, if x is in between negative pi over 2 and pi over 2, these will cancel. If it doesn't, then the answer is not x. Right? So here, if we have tan of tan inverse of x, we have to look at the domain of tan inverse. Right? And the domain of tan inverse was the range of tangent, and the range of tangent was all real numbers. So this one here is going to occur 100% of the time. If x is between negative infinity and infinity, these will cancel. Okay, this is the only one that's true. Right? So I kind of alluded to the fact that Sometimes we're going to have to translate the quadrant that these are in. Okay, so sometimes the answer is x, sometimes the answer is not x, but it's always going to exist. Right? Over here on this side, if x is not between -1 and 1, then the answer does not exist. Okay, there is no translating these. Right? So if they are, they cancel. If they're not, it's a different angle here. Okay, here, if it's in the restricted domain, then they're going to cancel, and if it's not, then the answer is does not exist. So let me put some examples here. All right, so let's do sine inverse of sine of pi over 2. So the question is, will they cancel and equal x, or won't they? So we have a regular sine function in here. So the angle is pi over 2. So is pi over 2 in the restricted domain of sine? Looking up here, the restricted domain of sine includes pi over 2. So the answer is yes, these will cancel, and the answer is pi over 2. Right? What is cosine of cosine inverse of 0? Okay. Will these cancel or won't they? So the inside function is inverse cosine. So the domain of inverse cosine is -1 to 1. 0 falls within that interval, so these are going to cancel, and the answer is going to be 0. Right. What is tan of tan inverse of 3? Right. Tan inverse is on the inside, so we have to ask ourselves, is 3 in the domain of tan inverse? Right, so the domain of tan inverse, all real numbers. Right, so this is always going to cancel, and we're going to get 3 as a result. Right. So what is sine of sine inverse of 1.25? Okay. So sine inverse is on the inside. What's the domain of sine inverse? Okay, the domain of sine inverse is -1 to 1. So since 1.25 is outside of that interval, then these will not cancel, and the answer is does not exist. Right? Now let me put a little tricky one on here. What is sine inverse of sine of 1.25? So notice I've kind of switched and put the sine inverse on the outside and the sine on the inside. Okay, so 1.25. Is 1.25 in the domain of sine? Well, the domain of sine is -pi/2 to pi/2. These are radians, and this is a real number. So what you have to do is you have to recognize these radians as real numbers as well. Right? So you know how pi is 3.14? Well, then pi/2 is half of that, right? So in real numbers, this kind of correlates to -1.57 to 1.57. Go ahead and calculate pi/2 on your calculator if you don't believe me, okay? But half of pi is 1.57. So in real numbers, 1.25 is indeed in this interval, okay? So these will cancel, and we will get 1.25. So watch out, be careful, right? What about cosine inverse of cosine of 3, right? Is 3 in the domain of cosine, or the restricted domain of cosine? So cosine is here, right? The restricted domain of cosine is, why did I write pi/2? I am so sorry. The restricted domain of cosine is 0 to pi. Apologies there. Oh my goodness. All right. So pi is a radian measure, and this is a real number. So pi as a real number is 3.14. So is 3 in that interval? Yes, it is, right? So it's in the interval. These are going to cancel, and we're going to get 3. All right? So let's do some of those examples where we have to transfer the quadrants. Okay. So what is sine inverse of sine of pi? Right. So notice the domain of sine. The restricted domain of sine is up here, negative pi over 2 to pi over 2. Okay. So this is not in the restricted domain, right? So we can't just say the answer does not exist here, because sine of pi does indeed exist, right? So if I were to calculate just sine of pi, right, I'm going to do a little unit circle here. Pi is over here. This is negative 1 comma 0, right? So sine of pi is 0. So I'm going to rewrite this as what's sine inverse of 0. Okay. So remember, this is the ratio, and the answer to an inverse trig function is the angle, right? So what I want to do is I want to translate and find the other coordinate on the unit circle where sine is 0. Okay, sine is 0 here, and sine is 0 here as well, right? Because this is the point 1 comma 0. So I'm going to translate the angle from pi over to this angle at 0, right? Because both of these have the same sine value. And so if the ratio is 0, then the angle is 0, right? And so the answer is not pi. The answer is the angle in the correct restricted domain. Let's do another one. Let's do sine inverse of sine of 3 pi over 4. Okay. 3 pi over 4 is in quadrant 2. 3 pi over 4 is 135 degrees, right? So it's over here. That's outside of the restricted domain, okay? This is bigger than pi over 2. So what I want to do is I want to translate this angle and this point to a quadrant that is between 1 and 2, right? So the point on the unit circle here was negative 1 over rad 2, positive 1 over rad 2, right? So sine of 3 pi over 4 is positive 1 over rad 2. So let's go ahead and write that. Okay, so what is sine inverse of 1 over rad 2? Right? What angle would get us a ratio of 1 over rad 2? You should recognize this ratio as a 45-degree angle. Right? So we need to translate to this point over here, positive 1 over rad 2, positive 1 over rad 2, where the sine values are the same, but the angles are different. So instead of the answer being positive 3 pi over 4, the answer is rather pi over 4. Okay? We translated it to a quadrant 1 angle. Okay? Let's do some cosines. Let's do cosine inverse of cosine of 3 pi over 2. Right? So is 3 pi over 2 in the restricted domain of cosine? No, it is not. Right? The restricted domain stops at pi. So what is cosine of 3 pi over 2? Okay, the point on the unit circle here is 0 comma negative 1. Right? So I'm going to rewrite this as cosine inverse of 0, because cosine of 3 pi over 2 is 0, right? So where is cosine 0? Where else is cosine 0, right? We get this point up here where the x value is 0. So the angle is not 3 pi over 2, but rather pi over 2. So we just have to translate it to the correct quadrant. All right, I have to stop the video or else I'm going to have to do this again. All right, good luck, guys, and if you have questions, please do not hesitate to contact me.